Let's go over this transformation question. We're given this graph on the left over here. Looks like there's a line segment and a semi-ellipse. Okay, it's not quite a circle, it's an ellipse. Okay, and we want to transform it to this one on the right. Okay, and left side is g of x. We want to write down what the equation of the right-hand side is in terms of g of x. All right, so we have to first remember this is not equation, this should be expression, I should say. Equation would be something with the equal sign, so my bad for there. But the general form is a times g of b times x minus h plus k. Okay, I would recommend you memorize this general form for transformations because this will come up once again a lot in the trig section when you learn about trig functions. So this will greatly help. Okay, so A is related to the vertical stretch and reflection. If A is positive, there's no reflection about the x-axis. If A is negative, there is. All right, and if A is bigger than 1, absolute value of A is bigger than 1, there is a stretch. Okay, if absolute value of A is less than 1, so like half or something like that, there is a compression. B is very similar, but it's related to the horizontal stretch and reflection. Okay. H, if you remember from other forms, like the vertex form of a parabola or the absolute value function, HK, that stuff. H is related to the horizontal shift. Okay, so if H is positive, you're shifting to the right. If it's negative, it'll be X plus something, you're shifting to the left. K is related to the vertical shift. If K is positive, you're shifting up. K is negative, you're shifting down. Okay, so now we have to basically get what A, B, not X, H, and K are from this to this. Okay, how do we do that? Let's start with the vertical stuff first, and then we'll get to the horizontal. Okay, let's go step by step. Let's not get overwhelmed by mixing and matching both vertical and horizontal. So let's tackle them one by one. And I would recommend that let's go into order of reflecting, stretching, and then translating, which is also shifting. Okay, so this is actually what a student taught me. They remembered the acronym RST, reflection, stretching, translation. That's the order that we need to go. By the way, why do we need to go in that order? It's order of operations. You have to multiply first, that's the reflection and stretching, and then you add the translation, the shifting. Okay, I went over in detail in a different video for why that's the case. If you need to go over it slower, I would recommend going to that video. Okay. Okay, so let's look. From the left to the right, clearly there's a reflection, a vertical reflection. You're flipping this over about the x-axis. Excuse me. So A is going to be negative. Okay, is there a stretch that occurred? Let's figure that out. There's a few ways we can go about this. For example, if there's a vertical stretch, the height of the semi-ellipse will be different. So let's count. So from the zero line over here, if we count the height, it looks like it's a height of 2. Yeah? Now what about over here? Let's go from the base over here at y equals 1 over here. Let's count. 1, 2, 3, 4. So there's a stretch by 2 because the height here was 2. The height here is 4. And look, it's opening the other way. So as we were saying, it should be negative. Okay, so A is going to be -2. That's one way to figure it out. Another way is we can take this line segment. What's the slope of this line segment over here? Slope is change in y over change in x. So we go down in the y by 3, and we go right by 1. So -3 over 1. The slope is -3. Okay, now what about over here? So how much up do we go in the y? We go 5, 6, and we go to the right by 1. So 6 over 1, which is 6. So you went from -3, a slope of -3, to a slope of 6. That's times -2. And that's what we were saying. A should be -2. That's what I'm saying in these 2 points over here. Okay? Now, let's figure out K, because remember, order, RST, reflection and stretching. We figured that out. Now let's figure out the shift. So look at these 2 points on the axis over here. Okay, if we reflect and stretch it, they won't change in terms of the y value, because 0 times a would be 0. Okay, it doesn't matter what a is, it will be 0 still, assuming they're finite. Okay, now look, these points are shifted up by 1. So this is why we go in order. K is 1 then. All right. So we handle all the vertical. Now let's handle the horizontal, the B and the H. Is there a horizontal reflection? So like did this line segment on the left move to the right-hand side? No. So we know that B is positive. Okay. Now is there a horizontal stretch or reflection? How can we count that? Well, again, we can look at the line or the semi-ellipse. Let's look at the ellipse. So what's the width of the ellipse? 1, 2, 3. Okay, that's on the left. Now on the right-hand side, 1, 2, 3. There is no stretching that occurred. And we can also confirm from the line. Remember, when we were calculating the slope, the delta x was 1, no change. So B is 1. No stretching or reflection. Okay, that's what I'm saying in this bullet point down here. And now let's scroll back up one more time. What's the shift that occurred? Well, if we go by this point over here, this is at x equals 1, right? Where did it shift to over here? It is x equals 4. So it's shifted by 3. So h is 3. When we shift to the right, h is positive, so h is 3. We found all the coefficients, so let's write it as minus 2 times g of x minus 3 plus 1. And this is how we tackle this problem. People are probably intimidated by this because they don't go step by step like I presented it here, and there's an ellipse looking thing, kind of intimidating, but well, it's not too bad, right? We actually use this ellipse to make this problem a lot easier. We counted like the height and the width of it to help us figure out the stretching. Okay, the line, you could also do that, but there's a little more computation needed versus the ellipse, we just counted. So actually, it made it a little easier, in my opinion, at least. So hopefully this helps you tackle similar problems if you come across this on your homework or exam.